Hello everyone, welcome back. As you all know me, this is Arshini from Sri Venkateswara College of Engineering, Bengaluru, currently pursuing first semester in the Department of Electronics and Communication Engineering. My today's subject is mathematics and the presentation is on radius of curvature of a polar curve. Before going into the video, please like, share and subscribe to my channel. In this video, let us see the introduction, definition, formula, applications and problems. Firstly, let us see the introduction of radius of curvature of polar curve. The radius of curvature measures the curvature of a polar curve at a specific point. It provides insight into how sharply the curve changes direction at the point. Calculating the radius of curvature helps us understand the behavior of polar curve. Now let us see the definition of polar curve. The radius of curvature at a point P on a polar curve is that reciprocal of the curvature at that point. It is denoted by R or rho. The radius of curvature measures the radius of the osculating circle which best approximates the curve and that point. Formula for radius of curvature of polar curve is rho is equals to r square plus r1 square to the power 3 by 2 divided by r square plus 2r1 minus r into r2. Next is application of polar curve. The radius of curvature is a measure how sharply a polar curve bends at a specific point. It is used in various applications such as analyzing the curvature of road curves in transportation engineering. Additionally, it is utilized in design of roller coaster and other amusement park to ensure a smooth and thrilling experience. In the physics and astronomy, the radius of curvature is employed to study the bending of light rays by gravitational fields. It is also utilized in optics to design lenses and mirrors with specific curvatures for focusing light. In biology, the radius of curvature is used to analyze the shapes of biological structures such as leaves, petals, and shells. These are some of the applications of radius of curvature of polar curve. Now let us see the problem of radius of curvature of polar curve, that is find the radius of curvature of the curve r to the power n is equals to a to the power n cos n theta. It becomes equation 1. By taking log on both sides we get n log r is equals to n log a plus log of cos n theta. By differentiating on both sides we get differentiation of n log r is n by r into r1 is equals to differentiation of n log a is 0 because differentiation of any constant is 0 plus differentiation of log cos n theta is 1 divided by cos n theta and differentiation of cos n theta is minus n sin n theta. Now r1 is equals to here n and n gets cancelled, here n and n gets cancelled, so in remaining is minus here r comes to numerator and goes to RHS, that is minus r into sin n theta divided by cos n theta. Sin by cos is tan, so r1 is equals to minus r into tan n theta. By differentiating again we get differentiation of r1 is r2 is equals to, here we have to use UV rule, that is u into v dash plus v into u dash, that is minus r into differentiation of tan n theta is secant square n theta into n minus differentiation of r is r1 into tan n theta. we know that radius of curvature is given by rho is equals to r square plus r1 square of 3 by 2 divided by r square plus 2 r1 square minus r into r2. Substituting R1 value and R2 value in the above equation, we get R2 plus R2. R1 value is minus R tan theta, as here square is available. R into minus R, we get plus R. So plus R square tan square n theta to the whole to the power 3 by 2 divided by R square plus 2 into again R1 square value minus R into R2 value is minus n into r secant square n theta minus r1 tan n theta, and here taking r square as common term and separating 3 by 2 to the both equations, we get r square of 3 by 2 into tan 1 plus, here after taking r square as a common, here 1 will be remaining, so 1 plus tan square n theta is secant square n theta divided whole to the power 3 by 2 divided by r square plus 2r square tan square n theta, here minus multiplying r into this term, that we get r into r is minus r into minus r, we get plus r square into n secant square n theta, n secant square n theta, and minus r into minus r1, we get plus r into r1 tan n theta. Next, here 2 and 2 gets cancelled, so remaining is r cube secant cube n theta divided by r square plus 2r square tan square n theta plus r square of n secant square n theta minus, here taking r into r1 is r square tan square n theta. Now r cube secant square n theta divided by r square of, taking r square as a common, we get r square into 1 plus tan square n theta plus after taking r square, we will get n secant square n theta, n secant square n theta. Here r cube secant square n theta divided by r square of 1 plus tan square n theta is secant square n theta plus n secant square n theta. Now rho is equals to r cube and r square gets cancelled, that is r, and secant cube n theta and secant square n theta gets cancelled, that is that is r secant n theta divided by 1 plus n, we will get 1 plus n. So consider it as a equation 2. To find the value of theta, we use equation 1, that is r to the power n is equals to a to the power n cos n theta, that is here a to the power n goes to denominator, and so r to the power n divided by a to the power n is equals to cos n theta. Now by taking reciprocal, we will get reciprocal of cos n theta is secant n theta is equals to a to the power n divided by r to the power n. They considered it is as a equation 3. Now substituting equation 3 in equation 2, we get rho is equals to, that is rho is equals to r divided by 1 plus n into a to the power n divided by r to the power n. Therefore radius of curvature rho is equals to a to the power n divided by 1 plus n into 1 divided by r to the power n minus 1. That is all about the today's video. Thank you for watching.